international expert with demonstrated credentials in teaching, research, consultancy and training, who will be the key person of this 5-day Gyan course on design of concrete structure reinforced with fiber-reinforced polymer bars, which is a potential area of concern. Hope you all will enjoy the benefit of this 5-day course. Today we are entering into first day technical session, which is on Introduction to Composites and its Structural Application, Production and Manufacturing of Glass Fibers, followed by quiz. I wish you all a happy and enthusiastic beginning. Professor, stage is all for you.
Perfect. Thank you. Thank you very much, Sneha. Okay. Can you all hear me?
Yes, sir.
Yeah. Very good. If you, how many of you are familiar with the fiber reinforced polymer material? Oh, that's half of you. So, okay, good. So what I should, please feel free to join the discussion. Okay. If you think I'm presenting something which you don't agree with, that's fine. Please let me know what you don't agree, what you don't agree.
Started early.
Okay. And also, if you need any clarification, maybe you are already working on some FRP materials and you know how you do it in a different way. Please feel free to let me know. Okay. So that's about fellows who are actually familiar with FRP materials. So how many of you are familiar with the design of reinforced concrete with FRP bars? Oh, okay. So it's worthwhile. That's good. How many of you are use reinforced concrete with steel reinforcement? Almost all. See, that's good. So the transition from steel reinforced concrete to FRP reinforced concrete will be very smooth. I hope by the end of these 4 or 5 days, you will be able to talk knowledgeably with good understanding of design with FRP bars. Okay, so that's our goal. So you have seen all these details already. So I'll just skip. There are a few slides that are there. I put them in long time back. So we know all this. And one thing I would, I invite you to interact with me throughout the course and also after the course. It's no problem. You can write to me, send me emails, that's my email ID. And for those of you who are students looking for PhD positions in University of Akron or anywhere else in India,
Put the print.
I'll be happy to provide you information. You can come and talk with me after the course, finishes like 1:30 or something like that. Please feel free to come and introduce yourself to me, and you can discuss whatever you think is needed for your career development. Okay. So I also have open invitation for all of you, those who are interested in PhD programs, even in mechanical engineering, electronics. Tell your friends, don't worry, just let them know, and then you apply for admission. The one thing we will need in our programs are two things actually. One is GRE score, the minimum scores required for GRE. So plan ahead, take your GRE exams, and also TOEFL. Speaking is important. Speaking you need 23. So those of you who plan to go to the United States for PhD programs, remember that you need speaking score as well. And I have been taking lots of Indian students. I have other students as well from all over the world, but a lot of my students have completed, Indian students have completed PhDs. Some of them stay back and they are having excellent careers there. And the economy is really, really hot. So what I mean by hot means a lot of demand for civil engineers in America and everywhere. I'm sure it's the same thing in India. And some of my students finished PhD, they came back to India, they are working in very good jobs. So a lot of potential for advanced degrees, okay? So even if your friends want to contact me, no problem. I know that you are all very good students, those who are looking for PhD programs, so just send me your information. In the worst case, what would happen? I would say, I'm sorry, I'm not able to help. That's all I can say, right? But that's the worst case scenario. In most cases, I will probably direct you to correct points of contact. Okay, so this is session 1. We'll just go through basics. So today I will introduce, this is in your brochure, but what we will do in these 4 days, I'm saying 4 days because 5th day we are keeping for just discussions, questions and answers and stuff like that. And if we are not able to cover all the material by end of the 4th day, we will also do some lecturing on 5th day. But 5th day we are trying to keep free, okay? That is Friday. So what are the course objectives? So are you able to hear me there? Very good. So, first of all, I will introduce you to concepts of FRP in civil engineering. So, in other areas, I will show you some pictures and present some material in other areas, but we are not really interested in, we have less interest in using FRP bars in other areas. So physical mechanical properties, fluxural design of FRP reinforced concrete members, and this is probably one of the more important aspects we will cover. You cannot replace steel reinforcement with FRP reinforcement. That's what everyone thought. Like 15 years back, 20 years back, FRP material was just beginning to be used. Everyone thought, oh, this is the next sliced bread. Okay, so there's a context to that. Sliced bread is considered to be staple food for Western culture, right? So like for us, rice and roti. So everyone thought that's the best thing that's happening to our industry. Did not happen. We could not replace all the steel reinforcement with FRP. First of all, it's not practical. There are hundreds or millions of tons of steel being used everywhere. For many, many years, they have been using lots and lots of steel. So that's not going to go away. So if you are thinking that we are going to replace steel reinforcement with FRP reinforcement, that's not likely to happen, okay? Steel will still remain the dominant construction material in structural engineering. FRP has its place. In some locations, you really cannot use steel bars. There's no way you can use them. I will highlight those areas where you need to use FRP rather than steel, or it's advantageous to use FRP instead of steel. So how many of you are familiar with corrosion resistant bars? Okay, what kind of corrosion resistant bars are you familiar with? Epoxy coated bars, very good. So are you using those? You are? Where? Okay, that's good. So there is a premium to be paid for epoxy coated bars, right? How much is that? Do you know? Like what I mean by premium is you need to pay slightly more for epoxy coated bars compared to black bars. We'll call it black bars, okay? Black bars means uncoated bars, regular reinforcement bars. How much? Do you know? Throw out some number. Don't worry, right or wrong, doesn't matter. I'm just trying to get a feel for numbers because I have my own numbers, but I want to see what the local numbers are. What is the premium, like additional cost for using epoxy coated bars in place of black bars? About 10%, 20%, 30%, 40%. How much? 10%. 10%. That's a good number because mostly it is 10%. That's very good. So I'm not trying to personalize this, but did you ever go to a site where they were using
epoxy coated bars? You have been. Any problems? No problems?
Yes,
Yes.
sir. The bonding between the reinforcement and the concrete
Yes. Please,
is
you
not
don't.
all good in epoxy.
Absolutely. That's.
Actually, that is the reason why people are not recommending fully the epoxy coated bar.
Okay. On Thursday, second session, I'm going to present some nice material on what the problems are with epoxy coated bars. There are many problems with epoxy coated bars. That aside, at site, what is the problem? The coating always gets damaged, okay? And if there is no proper inspection, nobody will know it. That's a big problem. You know why? Because if you have a steel bar, no coatings, that will have some amount of corrosion, fine. But if you have an epoxy coated bar, you have a small damage, localized damage at different locations, that will cause very accelerated corrosion. In fact, it's worse than the reinforcing bars without any coating. It's a big thing, okay? So don't assume that epoxy coated bars are the best and they can solve all our problems. Maybe not as much. There are a lot of problems with epoxy coated bars, just like you mentioned. Bond is a big problem. Of course, we adjust that by adding a 10-15% additional development length. That's one thing. But for any impact loading or any dynamic loading, epoxy coated bars will make the concrete simply crumble. I'll show you some of these slides. We have done a lot of work on epoxy coated bars. I'll show you how it does not perform very well under impact and dynamic loadings. So that's a problem. Okay, that's one of them. What about other types of bars? I'm just trying to get feel for what you normally use for corrosion resistance. Galvanized, very good. How much is that? What's the premium? Did you use, number one, did you use galvanized bars? So what's the premium for addition? Galvanized is nothing but zinc coat, okay? Zinc coat with a few other alloys. So how much is the premium? Zinc is a very expensive metal, by the way. So do you know how much is the premium? Okay, it's the suppliers will always say, oh, okay, we can match epoxy coated bars with galvanized steel, but they never do. It's probably slightly more, about 25%, I would say. And there are same problems with galvanized bars too. So they also, up to a point, they provide good resistance. After that, they don't. And in India, as of now, or even in America, most of the galvanized bars are fabricated by dipping. It's called hot dipping. So you have a very hot bath of zinc. Just dip all the bars into the bath, remove it. That's all you have. So it's a coated bar. But that hot dipped galvanized bars have a lot of problems. The thickness of the coating is very large. So we don't want to go into all those details, but when the thickness is large, you lose bond. That's a big problem, okay? And it has same problems as epoxy coated bars if the thickness of the galvanized coating is very large. So what this time they are doing is, it's a very new technique or technology they have developed now. What they are doing continuous galvanized bars. So instead of dipping everything, the steel bars, into a zinc bath, what you do is you have to heat it. So you have to heat your bar and pass through a very small bath, and it goes at very high speed. So it just gives very thin coating of continuous galvanized protection. Okay, that's something I'm working on right now. My sponsor funded me for doing some work, and it's looking very promising. But the price is slightly higher because what you're doing is you're heating your steel twice. Once while you're manufacturing, once when you are galvanizing. So that's the problem, because that costs money. Anything costs money if you heat it twice. Okay, anything else? They are dual coated bars. Okay, so zinc coating, on top of it you provide another epoxy coating. Okay, thank you. So zinc coated bars are provided with one more coating, and that would be your epoxy coating. Okay, so that's even more expensive than either zinc or epoxy coated bars. So that's another option, but it's very expensive option. The other one they are doing is, are you familiar with MMFX bars? So what they do is they add a little bit of chrome and nickel in your steel. By the way, chrome and nickel are very expensive metals, very, very expensive metals. You can increase your strength significantly by addition of those alloys, but at the same time it makes it very, very expensive. Then the strength goes up. They are even supplying 120 KSI, which would be about 830 megapascal steel. They are able to supply that. And ACI 318, which is the structural design code from American Concrete Institute, has adopted that high range of strength, which is brand new material. I'm not sure if they have come into Indian market yet, because it's very, very expensive material. But that's another option. And because of chrome and nickel, you'll have very good corrosion resistance. We have done a lot of corrosion testing on these bars. They are very, very good, except that they're very expensive. So where does FRP fall into this equation? FRP is expensive. It's not cheap. But at the same time, it's not as expensive as, let's say, stainless steel bar. How many of you have used stainless steel bars? Have you ever tried using stainless steel bars? Stainless steel bars? No. Stainless steel bars, there are a few grades. So that's a really expensive material. And very recently, like just 1 year back, we used in one of the bridge projects in our state stainless steel bars. We did use that. And because we just wanted to try those stainless steel bars. That's an option, but very, very expensive option. FRP is slightly cheaper compared to these expensive options. Okay, so that's where FRP falls. Now, at the end of the course, like I already mentioned, you will be able to design some small basic elements with FRP internal reinforcement. You can identify structural applications where it's useful to implement FRP reinforcement, but where it's not useful or expensive to use. So both, you'll see both. So I'm throwing out a few words here, terms. I say cost critical and performance critical structures. Okay, there's a lot of difference between the two. So if you are trying to build an airplane, the body of the airplane is very thin sheet, of course. They use FRP a lot. I'll show you some pictures. So for every pound of airplane weight, the cost is like hundreds of thousands of dollars, right? So the whole airplane will be, how much do you think airplane weighs? How much? Do you know? It's about 300 kips. 300 kips is about 300,000 kips divided by 2.2 is roughly, forget about the conversion. 1200 or 12,000? 12,000 kilonewtons. That's how much your airplane can weigh. Like 787 would be that heavy, right? So if they can make it, reduce the weight by even 200 pounds, the cost will reduce significantly. And they don't mind that. If you see all these fighter jets, MiG-27 and F-16s, all those, they are very sleek and they have lots of composites in that. So they can go faster if the mass is smaller. So they can use that and they don't mind the cost. How much ever it costs, it doesn't matter. They want the best plane, lightest plane that can go fastest, because they are in a different theater of operation. So that's known as performance critical structure. Okay, so in such structures, all these expensive materials can be used. They don't mind that. That's fine. But in a day-to-day application like a small building, let's say you're building a small 4-story building and you want to use FRP, that's not performance critical structure, but it's a cost critical structure. If you are bidding it for say X amount of rupees and somebody else can bid for less than that, the lowest bidder will get the job, right? You are competing there significantly. So that's a cost critical structure. So FRP materials cannot always be attractive in cost critical structures. You cannot use FRP. However, there are some applications where you can use FRP with a lot of advantages. So initially we thought this would be our course outline. We said we'll kick off our course at 9:30. We are a little bit behind, but that's okay. Then I will introduce you to composites, and then I say structural applications. This will be a lot of pictures, so it will keep you awake for sure. Then we'll talk about the basic composite material characteristics. We'll show how the fibers are produced. So composites means they have fibers, matrix, right? Two things. We are combining them. So you want to see how the fibers are produced and why are they strong? Why are they so strong? We'll talk about that. Then I will talk about some processes where you can actually make the composites, and then there will be quiz. That's scary part, right? That's the scariest part. So you'll have a big quiz end of each session. Now day 2, to be honest, if I take that quiz, I may fail. So don't worry. So the second day we'll do micromechanics. So how are the properties of fiber and properties of matrix? How do they interact with each other? How do we get the combined property by knowing just the properties of the two independent materials? Okay, we'll do that. Then we'll go through different common FRP bars. Properties ACI 440.1R is this document here. They're all electronic these days, so I can't show you electronic copies, so I've just printed something. So this gives you all the guidelines related to FRP bars. We'll talk about that in a minute, or tomorrow maybe. Then we talk about design philosophies and primary differences between American design methods and Indian standard 456. So IS 456 has its own stress block, which is not same as ACI stress block, and the loads, the factor loads that IS 456 uses are based on IS 875, right, the loading standard. So the loading standard has its own factored load, factors for the factored loads. So we'll talk about that. And then design material properties that we will use in our designs consequently. We'll talk about that, and then we'll present an example and quiz 2. So what we'll do is each day, like here, quiz 1, you take the quiz with you, go back to your room or wherever you are going back, and then the slides. Did we give them slides? Do you all have slides with you, or you do? Okay. Ideally, it will be helpful if you can open those files and keep them open in front of you, if it is possible. Okay. The email has been. Okay. So all the answers to the quizzes will be in your slides. So if you have if you need to refer to those slides, you can go back and take a look and answer those questions. Very simple questions. And then you do that, and you come back tomorrow morning, we will talk about what your answers are. Okay? That's the way it will be very simple. Don't worry about it. Then on third day, we will deal with flexural design basics, moment strength, Most of you are probably familiar with under-reinforced and over-reinforced concrete design. Is that right? I'm assuming. And in steel, what do you prefer? Do you want your failure to be by under-reinforced condition or by over-reinforced condition? That's very good. So everyone, almost everyone knows that in steel reinforced concrete members, we always want to fail the member by yielding of the steel. That way we will get very large deflections and some cracking, so that will give us warning, and therefore under reinforced condition is preferred. In case of FRP reinforced concrete, I will just give you a heads up, the over reinforced condition is preferred. Okay, I will talk about why that is preferred. That we will do on Wednesday, and then we'll go through some example. Then in the second session we will do strain compatibility method, because we will be using over reinforced concrete failures or over reinforced failure mechanism. We need to use strain compatibility method or something different. Okay, so how many of you are familiar with strain compatibility method? Okay, that's the reason I added this. I will present that. And strain compatibility method is a very powerful method to design anything. So you probably use that. You probably don't know that is called strain compatibility method. I'm sure you all designed some elements with axial load and moment, right? That is a strain compatibility method you will use in your strength interaction diagram. But I will explain that anyway. Then we'll talk about deflections, serviceability limits. Creep rupture is also a deflection criterion, and unlike in steel reinforced concrete, in FRP reinforced concrete, it's quite likely that creep rupture failure mechanism will govern your design. Okay, and then we'll go through an example. On Thursday we will talk about shear design. Shear design is, okay, let me back off. For steel reinforced concrete slabs, do you ever check shear? You probably do, but you don't have to, because shear will almost never govern your strength for slab design. Almost never. It's highly unlikely that shear design will govern your design, the design for slabs. So to the extent that in bridge codes, bridge design standards, they tell you not to even bother. You don't even have to check if it is a slab bridge. You don't have to check shear for design. Then we will talk about development lengths and splices. That will become a little bit tricky, because you'll need longer development lengths. I'll tell you why. We'll talk about that. And that will probably end the discussion on FRP materials. Those are, with that much, you will be able to design almost any slab, simple slabs, beams, and simple structures like that, precast elements and stuff like that. I'm not even mentioning columns. Does anyone know why I'm not mentioning columns? We'll talk about it later. Because FRP bars are no good. You don't use FRP bars in compression members. Therefore, you don't talk about design of compression members with FRP bars. In the second session, we'll talk about some research, that we have been conducting in my university, and we'll talk about basalt FRP materials, which are new. How many of you have heard basalt as a material? See, that's many people, right? But there are a lot of limitations for basalt material. We'll talk about that, because all these suppliers, they are just not telling you everything. Okay? They will not highlight the limitations of those materials. We'll talk about it. I don't have any personal interest, so I will talk about it all I want. And because these suppliers, they give me money to do the testing, but I tell them the answers they don't want to hear. But I don't have any problem with that. It's always good to know the limitations of your product, right? But they won't tell you the limitations of the product. We'll talk about it. So I'll present some stuff, and then we'll talk about research needs. those of you who are young faculty wanting to build your research profile, research